here at the schedule I've got projected. So I just want to point out where we are. Today we're going to talk a little bit more about the quadratic formula. And we have another quest coming up a week from, no, next week on Monday. So, yeah. Quest 4 is covering classes 19 through 24. So 19 through 24. So 19 is where we started factoring. Okay, so 19 through 24 is going to be factoring, solving quadratic equations, and graphing parabolas. Okay. 19 through 24. So that's Monday. Now today is the due date that I gave you for making corrections to Quest 3. So if you have those done, put them with your original test in your folder, and I'll try to get those back to you by next class. And you can get up to half the points you missed back. Okay, if you got your redone question correct. All right, so any questions on upcoming schedule? No? Okay, I'll remind you again Friday. We have a quest coming up on Monday. All right, so today we're going to look at how to use just a piece of the quadratic formula that will help us determine the nature of the roots of a quadratic equation. Rather than finding out exactly what they are, we could at least know what kind of numbers we're going to get. Right, so it'll be a little bit less work, but that's because, so we won't get the actual solutions, but we'll know what kind of solutions to expect. And we're also going to discover a brand new, totally new set of numbers that you've never seen before, probably, called the complex numbers. All right, so in our last lesson, we looked at this graph. This was a picture that appeared in our last lesson, graph D. And its equation is y equals x squared minus 4x plus 5. It's a parabola. And you can see it has no x-intercepts, right? It doesn't cross the x-axis anywhere. But what happens if we were to use the quadratic formula anyway, right? Remember, x-intercepts are solutions where the function equals 0, or where the equation equals 0. So if I try to solve this equaling 0, I'm not going to get a real solution, right? Because it has no x-intercepts. I can look at this graph and say there are no real solutions. But what happens if I do it anyway? All right, so I'm trying to solve this equation, x squared minus 4x plus 5 equals 0. And I'm going to use the quadratic formula, right? So the quadratic formula, I'll write it over here, was x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I know it's been a whole week since we've seen this. So we're going to practice plugging in here. Looking at this equation, 0 equals x squared minus 4x plus 5. What is a? 1. What is b? Negative 4. And what is c? 5. Good. So the a value is always the number attached to x squared. And when you don't see a number, you can assume there's a 1 there, right? The b value is the number attached to the x term. And the c value is the constant, the number with no x. So then I'm going to plug into the quadratic formula, replacing my a's, b's, and c's with numbers. And remember, when you plug in, always put parentheses around a number that you've replaced a letter with. All right, so my first thing is negative b. So I'm going to put negative, and then b is negative 4. So that the first negative sign came from the formula, and the second negative sign came from the fact that b is negative. So that says negative, negative 4, which will become positive. Yeah. All right, then I have plus or minus the square root of b squared. What do you get when you take negative 4 and square it? 16. So if I put negative 4 in parentheses, that will give me positive 16. If you forget the parentheses there, you're going to get negative 16, but it's actually supposed to be positive. All right, then I have minus 4 times a, which is 1, times c, which is 5, all over 2 times a, which is 1. So I just replaced all the letters in the formula with a number. And whenever I plugged in a number, I put parentheses around it. And now I just have to simplify this thing. So negative, negative 4, that is positive 4. So I've got positive 4 plus or minus the square root. Negative 4 in parentheses squared is positive 16. And then I have minus 4 times 1 times 5. Which, right, so I've got minus 20. All over 2 times 1, which is just 2. All right, so one more step here and I will stop. So I'm going to have 4 plus or minus the square root. 16 minus 20 is negative 4 all over 2. Okay, so this is where we were supposed to stop. We got 4 plus or minus negative 4, the square root of negative 4 over 2. Yes, Chantal. If you can, but you have to actually divide the 2 into both terms of the numerator. So I'm going to save it until I've simplified my radical. Yeah, I'm going to save that simplifying until after I do the radical. All right. So what is the square root of negative 4? What's I? Does anybody know what he's talking about? Yeah.
The square root of negative 4.
Think of a number. Yeah. So some of you appear to have heard of a complex number before. But if you have heard of it, pretend you haven't. Otherwise, try to think of a number, a real number, that when you square it, when you multiply it times itself, you get negative 4. So what are some potential numbers? Like 2. Does 2 work? 2 squared is positive 4, not negative 4, right? Okay, what about negative 2? Negative 2 squared is still positive 4. So there's no real number that you can multiply times itself and get negative 4. Okay, so we know from our earlier work this semester, simplifying square roots, that the square root of a negative is not a real number. But can we assign some meaning to the square root of a negative number? Okay, so far in your mathematical life, whenever you see a negative under a square root, you go, oh, that's nothing, right? It's just, that's non-real. Can't do it. But we actually can build a whole new number system called the complex number system. Okay. Complex numbers allow us to work with square roots of negative numbers. Complex numbers are used in many fields, such as engineering, and we use them to find quantities involved with electricity, and in medicine to calculate flow of blood in the bloodstream. But before we discuss, it's gonna like blow your minds, right? There are numbers that I've never heard of. That's crazy, right? But that's what happened throughout the history of math, right? Negative numbers blew people's minds when they were first invented. What do you mean negative numbers? How can you have a negative amount of something, right? But we started assigning a meaning to negative numbers that made sense to us, right? So, well, what if you want to go below 0? What if you owe money to the bank, right? So we at first felt like, what on earth are these crazy new numbers? But then they start working with them and you go, okay, these actually make sense and have a real purpose. Complex numbers are going to feel the same. At first, they're going to be like crazy, but then they'll start to have some more meaning. Okay, before we discuss the square root of negative 4, we're going to start with a simpler question, the square root of negative 1. So the question of how we define the square root of negative 1 arose when the 16th century mathematician tried to solve a cubic equation, right? We've never tried to solve a cubic equation, but something with a 3rd degree with an exponent of 3 in it. So their efforts in trying to solve that thing led to this whole new class of numbers beginning with this definition. We are going to let the positive square root of a negative 1 be denoted with the letter I. So we're just going to say whenever you're trying to take the square root of the number negative 1, we're going to call that I. It's just a new number, new symbol representing the square root of negative 1. So now we can find the square root of any negative number using our rules involving radicals from a few lessons back. So if I want to take the square root of negative 4, I could rewrite that as the square root of negative 1 times 4. Does that make sense? Just rewrite -4 as -1 times +4. And then I can break that radical into 2. So that's actually the square root of -1 times the square root of 4. And what's the square root of -1? I. What's the square root of 4? 2. So the answer to this is actually 2i. Okay, so 2i is the number that when you square it, you get -4. We just invented it. We just made up a number that when you square it, you get -1. We're calling it I. All right, let's do the same thing for the square root of -49. We'll rewrite that as -1 times +49. The square root of -1 times +49. Break it into 2 square roots. Square root of -1 times the square root of 49. What's the square root of 49? 7. Square root of -1? I. 7i is the number that when you square it, you get -49. All right, one more. Got to be a little bit tricky on this one. The square root of -12. I'm going to do something similar. I'm going to break this into the square root of -1 times 12, which is the square root of -1 times the square root of 12. But the difference between the previous 2 examples and this one is that 12 is not a perfect square number, right? So it's not a perfect square, so I can't square root it, but does it have any perfect square factors?
Yeah.
What?
It's going to be 3 times the square root of 3.
Yes.
4 times.
2 times the square root of 3. You pulled the wrong number out. Yeah. Yeah, so I could rewrite 12 as 4 times 3. So the square root of -1 becomes an I. And then the 12 rewrite as 4 times 3. And that becomes I times the square root of 4 times the square root of 3. Right? And then the square root of 4 becomes a 2. So this is going to be 2I times the square root of 3. Yes, Amy.
I know that you made up this
I is the square root of -1. Yeah, so whenever you have a negative underneath a square root, you can think of it as, yeah, so you can pull it out. Yep. Yep. No, because the quest is covering 19 through 24, and this is, yes, this is 24. Yes, this is going to be on the quest. Yep. Okay, I know, I told you, it's going to be like, all right, there's a number that you can square it and get a negative. Okay, we just made it up. Just like we just made up negatives. Okay. So in general, if you want to take the square root of a negative number, square root of -k, you can always simplify that as just I times the square root of the positive k. Whenever you have a negative under a radical, you can pull it out and turn it into an I. So numbers of the form a plus bi are called complex numbers. Okay. Complex numbers. If b is 0, right, then 0 times I is 0, and you're just left with the number a. That's a real number. Okay. So all real numbers are automatically complex numbers. They just don't have an imaginary part. Okay. So finally, we can finish solving this equation. 0 equals x squared minus 4x plus 5. So we had gotten this far, right? We had gotten to 4 plus or minus radical -4 over 2. 4 plus or minus the square root of -4 over 2. All right, so now I'm going to finish simplifying this. Square root of -4 simplifies to 2i. We just did that a couple minutes ago. So this becomes 4 plus or minus 2i over 2. And then Chantal had asked me, can you cancel the 4 and the 2? You can, but you have to divide that 2 into both terms of the numerator. So this would become 4 over 2 plus or minus 2i over 2. You have to divide that 2 into both pieces of the numerator. 4 over 2 is 2 plus or minus 2i over 2. The 2's cancel and you get I. So 2 plus or minus I. Those are the solutions to that equation. And they have i's in them, which was to be expected because we knew that there were no real solutions.
But that equation isn't 2 answers because it's positive Or negative?
Yes, yep, 2 plus I and 2 minus I, right? That's what the plus or minus means. So 2 solutions.
You're going to want to see that on the top.
You can write plus or minus. You can use
You're
the,
not going to want to see the two answers?
well, if you use the shorthand, I will assume that you know that that means there are 2 answers. Yeah. So they have I's in them. The reason that happens is because we knew before we even started, by looking at this graph of x squared minus 4x plus 5, that it is never 0, right? It never touches the x-axis. So there are no real solutions, which means when I use the quadratic formula, what I get are complex solutions, solutions that have I in them. Only in that situation where the parabola has no x-intercepts. Yep. All right. Is there a way to figure out how many solutions and what kind of solutions a quadratic equation has without going through the entire quadratic formula, right? So we just did the entire quadratic formula and found 2 complex solutions, right? But what if we didn't have to do the whole thing? So below each graph, you're going to see the nature of the solutions of each quadratic equation, finding the x-intercepts. And just remember that a rational number can be written as the ratio of 2 integers. So a rational number means fraction. You can write it as a fraction. And numbers with radicals are irrational. I don't know where that word went. Irrational. All right, so this first graph, for x-intercepts, it goes through the x-axis at -6 and at 1. Those are nice rational numbers, right? So we have 2 solutions, and they're both rational. Graph B, it touches the x-axis in just one spot at x equals 2. So we have just one solution, and it's rational also, because 2 can be written as 2 over 1, so it's a ratio. All right. Graph C, I have 2 solutions, but it doesn't look like they go through nice points, right? So I have 2 solutions, but they're both irrational. Sorry. And then in graph D, I have no real solutions. It does not cross the x-axis, So I have 2 complex solutions. No real solutions, but you'll always have 2 solutions that are complex in this scenario because of the plus or minus I, right? So you'll have 2 complex solutions. All right, so I can see visually what kind of solutions I'll have and how many. And we can also determine it using an algebraic method. So for the quadratic equation, ax squared plus bx plus c equals 0, the discriminant is a quantity determined by b squared minus 4ac. So the discriminant is just some number, it's b squared minus 4ac. Where have you seen that quantity before? Under the square root in the quadratic formula. It's the number that shows up under the square root from the quadratic formula, right? So it's the number under the square root that tells you whether you're going to have a real solution or a complex solution. Because if that number under the square root is negative, you're going to end up with some i's in your answer. If it's positive, you're going to get real solutions. All right, so I've got my, my 4 graphs. We just looked at the graphs earlier. Those are the equations. I want to find the discriminant for each one. B squared minus 4ac. All right, so in this case, what is b? 5. So I'm going to have 5 squared minus 4 times a, which is 1, times c, which is -6. Okay, so that's 25. And I have -4 times 1 times -6 plus 24. Negative and a negative makes plus 24. So that comes out to 49. So the number under the square root is 49, right? It's a positive number. And what's the square root of 49? 7. So it's a positive number and it's a perfect square. So that's going to mean that I have 2 rational solutions, right? If you can, yeah, if you can, because b squared minus 4ac, you're going to be square rooting when you use the quadratic formula. So you want to think about what will happen if this is the number under the square root. We'll be able to square root it, and you're going to get 2 nice solutions. No radicals left at all. Rational. All right, next one. In this case, b is -4. So I'm going to have -4 squared minus 4 times a, which is 1, times c, which is 4. So -4 squared is 16. 4 times 4 is 16, which is 0. What happens if that number under the square root is 0? You're going to have one solution, right? Because it's going to be something plus or minus 0. And when whether you add 0 or you subtract 0, you're going to land in the same spot, right? So in this case, we have one rational solution. That's going to touch the x-axis in one spot, right? This is graph B. This one rational solution. All right, let's look at equation C here. In this case, my b value is 2, so I have 2 squared minus 4 times a times c. So 2 squared is 4 plus, because I have -4 times 1 times -5 plus 20, so that is 24. It's positive, which means I'm not going to have any i's. The only time you get i's is if you have a negative under the square root. So it's positive, but is it a perfect square? No, which means I'm going to have some radicals left in my answer. I'm not going to be able to get rid of them altogether. So that means I'm going to have 2 irrational solutions. I'm going to have 2 solutions because of the plus or the minus. Plus or minus. But I'm going to have some square roots in that answer. So it's going to be irrational. All right, last one. B squared, so that's going to be -4 squared minus 4 times a times c. So -4 squared is 16. -4 times 1 times 5 is -20. So that comes out to -4. That's the number under the square root, -4. I'm now, if I'm going to try to take that square root, I'm going to introduce some i's, which means that I'm going to have 2 complex solutions. Negative under the radical means you're going to end up with i's, which is complex solutions. Yes. Yes. Yeah. So what you need to think about is what happens when you square root these. Yeah. Yeah, it would be something plus or minus 2i over something when you do the quadratic formula. You can put the square root there, Amy, but if I ask you to find the discriminant, I'm asking for b squared minus 4ac, not the square root of it, right? So thinking about what happens when you square root it is how you determine the nature of the solutions. Yeah. Yeah, exactly. Yeah. Yes. Yeah. No, for solutions, I want you to actually use the whole quadratic formula and solve it. Yeah. All right, so here are our conclusions for the information we get from the discriminant, right? If b squared minus 4ac is 0, one rational solution. B squared minus 4ac is negative. That means that you're going to try to take the square root of a negative, which will lead you to 2 complex solutions. If b squared minus 4ac is positive and a perfect square, then there are 2 rational solutions. If b squared minus 4ac is positive but not a perfect square, 2 irrational solutions. Sure. Yeah. Well, you were allowed to bring 1 page of notes with you to your quest, so I would put the quadratic formula on it for sure. And also the value of the discriminant, b squared minus 4ac. And you can write these down if you want to. You can have anything written you want on 1 page of notes for your quest. Yes. Oh, I don't know. That's correct. I'll think about it. Yeah. Okay, so now you have some activities. To clarify, Lena asked me if when I ask for the solutions, do I mean the number of solutions? No, I mean the actual solutions, right? So for the discriminant, that's just calculate b squared minus 4ac. Use that value to figure out how many and what the nature is, right? 2 irrational, 2 rational, 2 complex, 1 rational, right? Then actually solve it using the quadratic formula. Yes. In class 22, the class 22 homework, when you pull it up, there's only 1 question. Okay, it's just question 1. Click it. Right. Yeah. So there are four graphs that you're supposed to just graph, right, on graph paper. And so there's no help me solve this, there's no check my answer, right? All you do is select this choice when you've completed the assignment, right? And you'll get 100. So you just choose option A. But the question is, how do you know if you did it right, right? How do you know if you actually drew these graphs correctly? Because my math lab can't tell you. So there is some free graphing software called Geogebra. It's on all the Math Studio computers. I believe it's on the library computers also. And it's free, so you can download it if you want. You just go to geogebra.org, and I'll write that down in a second. But I have it on this computer. I'm going to show you how to use it. So let's say I want to check, what does the graph of y equals x squared minus 8x plus 12 look like? So you would have found the x-intercepts, the y-intercepts, the vertex. You do all this work to figure out how to graph it. And then you want to see if your graph is right. So I'm going to close all this stuff. All right, so GeoGebra is this right here. It looks like a Stonehenge. Okay. So you double click it. All right, so this is a free graphing software. Again, you can download it on any computer, geogebra.org, and I'll write it down. But I want to graph y equals x squared minus 8x plus 12. This table over here, Lena, can you guys just not talk for just a minute? Thank you. X squared minus 8x plus 12. So I go to GeoGebra, and in your input bar at the bottom, you can just type in any equation you want, and it will show you the graph. So we're going to do y equals x squared, and you use the little caret for an exponent. It's just shift, then the number 6, minus 8x plus 12, I think was the equation. So you just type it in exactly like that, hit enter, and it graphs it for you. Okay. So whatever you drew on your graph paper, you can then graph it on here and check that it's right. Okay. So this is a way that you can check your work.
I thought it helped me a lot.
Good.
I mean, it doesn't give you the answer, but it doesn't look like that.
Yeah, it gives you pretty much the answer. Yeah,
well,
but
it does, but you still
you do. Yeah, yeah, and it's not going to help you on a quiz or a test, right? But it helps you just check your work on your homework. Yeah.
Right.